Welcome to my podcast, Jack to the Future. From science and inventions to pollution and recycling, I talk about what's changing in the world, the future, and how we can help with that. Every month I'll talk about a different future theme. For example, the future of science, tech, sustainability, reading, music, and all sorts of other ones. The future of everything. Did you know? You can find me on Facebook and Instagram as Jed to the Future and on YouTube as Jack to the Future. Follow me to get behind the scenes info, access to the previews about my next episodes, and much, much more. This week's episode is about the future of maths. My guest this week is Chris Budd from the University of Bath. We talk about different types of maths, why people might find it more difficult than others, how maths might be taught in the future, inventions that use math, as well as talking about several famous mathematicians and how they influence technology in the world around us today. As you may know, maths is one of my favourite subjects. We have read an article on the Metro website that talks about whether we're running out of numbers. What's the biggest number you can think of? I'd probably say it was something like Google Plexion or infinity. My mum was saying that infinity plus 1 is still infinity because it's going to have a bunch of zeros at the end, and even if you times it by infinity, infinity times infinity, infinity squared, it's still going to be infinity. And infinity isn't actually a number, it's just an idea. It's technically just a name. Maybe, perhaps in the future, we might need a number that's bigger than infinity. But maybe it's not much about the bigger the number is, it's about how small the number is. So physicists think that we're not running out of numbers. But if you're doing coding, we actually are. So maybe not having enough numbers in the future will be a problem. What do you think? Did you know that it was Maths Anxiety Awareness Day on the 10th of November? A lot of people have maths anxiety. It's defined as
a negative emotional reaction to mathematics, leading to varying degrees of helplessness, panic and mental disorganization that arises among some people when faced with a mathematical problem.
Now that sounds long and complicated, but my mum said that she remembers feeling a bit like that as a child. You get given, I don't know, a times table sum maybe, don't know it, and then you try and solve it quickly. You feel under pressure, you start to sweat, your mind goes blank. You can't seem to even work up the simplest of calculations in your head. You panic, feel upset and confused, and likely don't get the answer right or answer the sum at all. Sound familiar? Well, you're not alone. I'm lucky that I don't have this. Like my guest, maths actually helps with anxiety because I enjoy it. But everybody's different, and for people who have these really negative feelings about maths, it could actually stop them wanting to learn any more maths in the future. I don't think that the media helps with this always, because maths is sometimes reported to be something that only brainy people could do it, or may be sexist about who's good at maths. This may cause people to think that maths isn't for them or something that they can do. The Department for Education published a report in January about skills needed for different jobs. And one of the things it says is that sometimes adults don't carry on learning, which means that we don't have enough people doing jobs like engineering, health workers, that kind of thing. So perhaps the future of maths is actually about teaching maths differently, or supporting people to feel more confident about maths in the things that they all enjoy and like doing, because after all, we do need maths, and well, it's everywhere, isn't it? You get up in the morning, look at the clock which has numbers on it, maths. Be able to tell the time in the first place, maths. The clock itself and its design, maths. Baking breakfast and estimating how much milk you need to soak up just enough in your Weetabix, maths. Folding up your pyjamas, maths. You get the picture. So a future without maths is really a future that doesn't exist. Maths has the power to influence so much of the future, but can it predict the future? What do you think? My guest today did a number of lectures on maths in the modern and future world. My mum will put a link in the description, and they're really interesting. Since Isaac Newton, we've got used to science predicting things, but some things are very hard to predict. Chris talks about how maths can be used to predict patterns in things like climate change and COVID. You can use formulas that Chris will explain to help with this. In math and science, there are lots of different models. These are like rules we can apply to different things, and that might actually help us to predict the future. For example, did you know numbers beginning in 1 are much more common? If you go and look through a newspaper or magazine right now, the majority of numbers will begin with the 1. This is called Benford's Law. Instead of having a crystal ball and predicting the future, rather, maths lets us notice patterns, help us make guesses about what could happen in the future. There is some mathematicians in America who are able to predict, using patterns, about which bits of the city are more likely to be burgled. And they made this into an app and gave this to the police. They reduced the number of burglaries by nearly a whole quarter. Maths can be really helpful in real life. I'd like to welcome my special guest today, Professor Chris Budd, based at the University of Bath. Thank you for being here today. Hello.
Hello, Jack.
My absolute favourite subject is definitely maths.
Well, do you know what? It's my favourite subject too, so that's good.
Yay! You're a professor of applied maths in Bath, is that right?
That's right. So that's the one I get paid to do. But I do other jobs which I don't get paid to do. So I work for Gresham College. Until quite recently, I was their professor of geometry. I've just handed it over to somebody else. And that job means I give lots of lectures to the public for them. And that professorship was started a long time ago by Queen Elizabeth I. So it's a very old professorship.
Wow.
And I have another professorship. I work for the Royal Institution, which is in the middle of London, and I help them do their math stuff as well. And so they have things like Christmas lectures for children, which you can watch.
So Christmas maths, basically.
Well, I also do a lot of things we call masterclasses, which are special extra maths lessons for people slightly older than you, so 11, 12, 13-year-olds. And we do those on a Saturday morning.
Cool. That sounds exciting.
Yeah.
But I'm not old enough, unfortunately.
Not yet. Just wait a little while and you'll have your chance. Don't worry.
Yeah. Will it carry on? Or
yes, we've been running these masterclasses for 30 years now, and we run them all around the country.
Yeah, well, what sort of maths is it? Is it like complicated equations or less? Or...
Well, it changes from week to week. So, for example, I gave a class recently all about how Google works.
Wow, that's complicated.
And somebody else is doing one on code breaking, so you can be a spy, or you could learn about, a really good one. Someone did a class about deep sea diving. So if you're a diver, and how to work out how much air to take, all the maths of that. So I thought that was really fun.
Yeah. There's so many different subjects. Like what you said, for example, I don't know, religion. That's probably still does have something to do with maths.
Well, there is something to do with that. I mean, there's lots of bits of maths. For example, in the Bible, they talk about how many fishes were caught by the fishermen, and that's kind of a bit mathsy. But religion tends to be in a sort of what we call a different area from science and maths.
Yeah.
They're kind of looking at different questions.
Yeah. You know, maths and science have loads to do with each other. Science technically has something to do with every single subject. Everything that you do in every subject, when you speak words, the air comes out of your vocal cords, that's still math and science, because what happens in the air when it vibrates.
That's right. And one thing I actually work on is what's called natural language processing. And what that means is there are things around like Alexa where you speak to it and it understands what you're saying, and then you can do
artificial intelligence.
Right, absolutely right. Well, there's lots and lots and lots of maths in artificial intelligence. So it's one of the big areas that maths is being used nowadays is in artificial intelligence.
Because all the programming, I can imagine.
All the programming and all that sort of stuff, yeah. But they hire lots of mathematicians to work for them. And I mean, here's my smartphone, and there's lots and lots of maths that goes on inside one of those to make it work.
Yeah.
Which I find super exciting.
Even this computer that I'm looking on to do Zoom right now has all inside it.
Yeah. Well, the computer was sort of invented by mathematicians.
Yeah.
The first computer was invented by a guy called Charles Babbage, who was a mathematician.
Yes,
and someone who worked for him was a lady called Ada Lovelace, and she wrote the first computer program, and she was a mathematician. And then in the Second World War, there's an amazing guy called Alan Turing, you may have heard of,
Yes.
And he invented the first sort of electrical computer. And then after the war, he made even better computers. And my favourite one of all, you may not have heard of him, it's called von Neumann, who was an American mathematician.
Yeah.
And nearly every computer we use nowadays is based on things that von Neumann thought of. So, yeah, there we are.
I've read a book called Evil Inventions, which is based on horrible histories, and in it there's a computer chapter where it talks about all about computers, and it mentions Alan Turing, Albert Einstein, and loads of other maths. And it didn't mention Ada Lovelace, but I've got that in a different book.
But Ada Lovelace is an amazing person, and that was a long time ago, and that was when computers didn't work on electricity like they do nowadays. They worked on having cogwheels, and if you go to the Science Museum, you can actually see the computer that she worked on. Well, to be accurate, they've rebuilt it, so it's a kind of reconstruction, and that's pretty amazing. You should maybe go and have a look at that.
It's my favourite science museum ever, basically.
Shall I tell you what a professor does?
Yeah.
So every day is different for me, so it's hard to really tell what a professor does. But I do sort of 3 different types of thing. So the thing that you probably most think a professor does is I teach lots of students. Most days I've got students at Bath and they come and I give them talks about different bits of maths. So that takes up a lot of time and it's very exciting because students are really exciting, interesting people. Then if I'm not doing that, I spend a lot of my time trying to solve maths problems. Now, different professors work on different types of problem, but the sort of problems I work on are problems where maths is used in the real world. That's because I'm called a professor of applied mathematics. So I'm working on problems like climate change at the moment or COVID. Done a lot of work on weather forecasting. I've done a lot of work on cooking and food and stuff like that. And I do a lot of work on things like electricity. And then the third thing a professor does, and you might find this a bit strange, is I spend a lot of time trying to get money, not for me, but to pay for people to work in the university. No,
I don't think that's strange.
So universities have lots of people working for them. The job of a professor is to make sure that we get the money to pay them to work. So I actually have a big team working for me. I like going into schools and talking about maths. That's one thing I like doing. Or some of my best friends are really heavily involved with working with government at the moment to try to stop COVID and all that sort of stuff.
Yeah, totally. I think COVID, climate change, and all the big problems in the world right now, as you said, they all need helping. Yeah.
Well, maths is very useful in all of them.
What is geometry? Do you have a favourite shape?
Do I have a favourite shape? That's a great question. So I do have a favourite shape. I'm going to try to describe it to you. I don't have it with me at the moment, but I'm going to ask you to imagine it. So my favourite shape is a shape which from one angle looks like a triangle, another angle looks like a square, and from another angle looks like a circle. So you might want to go off and try and think what that shape might look like. The reason I like that shape is that one of the things I also do is I work with hospitals to help with what's called medical imaging. So if you go into a hospital, you can get scanned nowadays to see what's wrong with you. And a lot of scanning looks at shadows that are cast by X-rays. And that shape is, if you look at it in 3 different ways, looks like 3 different things. And that's helpful when we do scanning to make us understand what's going on inside the body. I'll try and show with this cup. So from that side, the cup looks like it's sort of squarey with a handle.
Yeah.
But if I do it this way, it looks like a circle.
Oh, yeah. It depends on the way you look at it.
Depends on the way you look at it. That's it.
Yeah. Circle, square, and a triangle. It would be a square.
A squangle, maybe. I don't know. So what's geometry? To answer your first question, geometry, it's a very old subject, goes back thousands of years, and it's the study of different shapes. That's what it is.
What is probably the most unused shape, do you think, Chris?
Unused shape? Gosh.
Yeah.
I don't know. There's so many shapes out there. It could be almost anything, really. So you've got obvious shapes like squares, triangles, rectangles, hexagons, pentagons, icosahedrons, dodecahedrons.
Favourite is a dodecahedron.
Right. Aha. But another favourite shape of mine is what's called a truncated icosahedron, which is the shape of a football. Well, a traditional football, when you have hexagons and pentagons glued together, that's a great shape.
Yeah, I like that one.
One of the most famous results in geometry is very old. It was, we think, discovered by the Chinese thousands of years ago. And then later it was rediscovered by somebody called Pythagoras. And it's all about a right-angled triangle. And if a right-angled triangle has a hypotenuse of length C and the other sides are A and B, it doesn't matter what the triangle is, a squared plus b squared equals c squared. And that's a formula in geometry, and it's called Pythagoras' theorem, and it's incredibly important.
Yeah. I see that 70% of jobs needs maths, but a lot of people find maths hard. What do you think could be done in future to make sure everyone can get a job, even if they're not very good at maths?
Well, remember, that means that 30% of jobs don't need maths, so that's lots of jobs people can do. Most of the jobs which require maths don't need too much maths. So if everybody can do GCSE maths, then that will give them the maths they need. A lot of people do GCSE maths and then stop doing any more maths. And one idea is to help people who are not so good at maths do more maths after that, but make it as fun as possible so that they really enjoy it. People who find maths hard often still find it useful if they apply it to their life. So if you talk about the maths of, say, going to the shops and making sure that you do your shopping cheaply, or the maths of making sure that you have the right sort of food to eat. And you need to know how many calories there are in the food if you're on a diet, like me. If you're cooking something complicated, like a Christmas dinner, then different things take different times to cook. And trying to work out where to put each one in the oven so that they all come finished at the same time is really quite tricky, really, especially if they have to have different temperatures and all sorts of things. It's a complicated operation. So I think that would make it much easier for people to like doing maths, and therefore they'll learn more maths. Yeah.
I think one job that needs maths, like loads of maths, would probably be building computers and doing coding. So
it does need a lot of maths. But the people that do that usually like maths and do a lot of maths at school.
Yeah.
Well, I think what you're doing, Jack, is brilliant. We need exactly people like you doing podcasts about interesting things like maths to make other people like you interested.
Yeah, even though, because if lots of people have maths anxiety, then they probably want to listen to this, understand why it's good to do maths.
I think they're much more likely to listen to someone like you than they are to listen to someone like me, because I'm, old and boring, whereas you're young and interesting. So, carry on the good work.
Thank you. But I think you're probably better than me.
I wouldn't say I'm better. I'm just a bit older than you. One of the things about maths, which is a bit worrying for people like me, is that nearly all of the really good maths is done by young people.
Exactly.
Yeah. Some people have made incredible discoveries in maths before they're even 20. 20 might seem really old to you, but it's really young to me.
I mean, all adults want to be 21, don't they?
Absolutely, 21. I'll tell you a story. There was a French guy called Galois, and when he was about 20, made a huge discovery in maths, a huge discovery, and he solved a problem which people have been trying to solve for about 3,000 years. And that discovery is really, really important nowadays in things like mobile phones and CDs and stuff.
Wow, when was this?
It was around about 1830, I think, so it was 190 years ago. Ever since then, we've always called his work Galois theory after him.
The Galois theory? Wow, that's amazing. Well, what was the discovery?
So he discovered a branch of maths which we now call group theory, and it's all to do with symmetries and patterns and stuff like that. And at the time, he just was interested in it because it was fun and interesting to him. But then we found that you could use it for all sorts of other things.
Wow.
Yeah.
Is it a type of coding?
It can be used in coding. Yes, exactly right. Yeah. Unfortunately, you don't learn about this at school. This guy was so super clever. It's really super hard stuff. So you don't learn about it till you get to university. He may not have even been 20. Some people think he was 17 when he did most of the work,
Wow.
Which is crazy.
Was it his favourite subject, maths, like you? Was it just one of his hobbies?
He had two favourite subjects, one which was maths and the other which was politics. So maybe you should learn about him.
Do you think play is how maths will be taught in the future?
I think that's a brilliant way of teaching maths. And I think the more people can get used to maths being just fun and playful, the more they'll enjoy it and then the more they'll learn. So I just hope we can teach more play-type maths. I love maths and magic tricks, for example.
That's the next question.
Maybe I'm jumping the gun. But a lot of play involves just discovery and exploring.
Yeah.
Lots of mathematicians like the Rubik's Cube. I have a very good friend called Matt Park. You can learn about it. He's on the YouTube quite a lot, is Matt. And he's a juggler and a mathematician. And he can simultaneously solve and juggle 3 Rubik's Cubes.
At the same time?
At the same time. He's a complete maniac and brilliant. He's wonderful. You should look him up. He's fantastic. If you type his name into Google, it'll just explode. He does so many great things. You'll like him.
Can't wait. I loved your mathematics games in the lecture that I watched on YouTube. And it was the video where you get a number, let's say 3, 2, 1, and then you verse it, and you did 2, 3, 3, 2, 1 minus 1, 2, 3 was whatever. And then add the two together, and then it comes out with 1089.
Yeah, 1089. Isn't that wonderful? Yeah, it's amazing. Wonderful magic trick, that. Yeah.
What is the orange kangaroo from Denmark trick?
Now, let's see. Up here. Here's my orange kangaroo. So the thing is, you have to think of a number between 1 and 9. Don't tell me it, just think about it. And then you have to multiply by 9.
Yeah, I got it, the number in my head.
Yeah, now take the digits of that number and add them together. So if it was 18, you'd add 1 plus 8. Okay.
Yeah, I got it.
Yeah. Now subtract 5. Then you have to think of a letter. If it's 1, you think of A. 2, you think of B. 3, think of C, and so on and so on.
Okay.
You should have a letter. Yeah. And now you think of a country that begins with that letter. So if the letter was A, you would think of Australia, for example. And if it was B, you could think of Belgium. So you have to think of a country that begins with that letter.
Denmark. That's what I thought.
And then you think of the last letter of that country, and you think of a nice big animal that begins with that letter. And then you take the last letter of that animal, and you think of a colour that begins with that letter. And if you get it right, you've got an orange kangaroo from Denmark.
Yeah, I got that.
The way the trick works is that any number, if you multiply it by 9 and add up the digits, you always get 9. So, for example, 6 times 9 is 54, and the digits of 5 and 4 add up to 9. And then when you take away 5, you always end up with 4. So the letter is always D, and there's very, very few countries that begin with D, and most people choose Denmark, and then you're off. It can go wrong if people choose a different animal, but most people choose kangaroo. I was very sneaky, so I say if it's A, think of Australia. So people are starting to think of Australia, you see, and so they think of kangaroo.
What is an equation?
Well, an equation is an expression, normally using letters, where you have different things and it kind of means something, and normally you have an equals somewhere. So
whenever somebody shows me an equation, I always think of Albert Einstein, and I think E equals mc squared for some reason.
Yeah, well, that's possibly the most famous equation ever, E equals mc squared.
Yeah, I can't remember. What is it?
Well, c is the speed of light, and the speed of light is very big, and E equals mc squared says that the energy in, say, a pen, if you took all the mass and converted that to energy, it would be incredibly large amount of energy. Unfortunately, it led to the atom bomb.
Yep.
But the thing is, the formula tells you about nature and how nature works, and unfortunately, nature can end up being used in that way, but it doesn't have to be.
Yeah, it doesn't have to be. No. And my absolute favourite person, who does maths and science, is definitely Albert Einstein.
Oh, he's amazing. Absolutely amazing.
Yeah.
Really clever guy, Einstein.
Yeah. Can equations predict the future? Can you give me an example?
An equation which predicts the future. It's hard. Some things are easier to predict than others. So I'll give you an extremely easy example. Suppose I have something here. This is some sellotape. And if I drop it, okay, I can write down the formula which will predict when it hits the computer. So that sort of predicts the future, and I can write a formula to do that.
So you can write the amount of seconds?
I can write the exact amount of seconds it will take before it hits the computer.
You could get a ruler and you can measure the length of where it is in your hand all the way to the computer.
Why don't I write the formula for you?
I have a photograph on social media of the formula Chris had just shown me if you're interested.
Now, another formula, which I won't write down because it's super complicated, is the formula we use to predict the weather tomorrow. So it's quite a long formula. It takes about a page to write it down. So that way we can predict some things. Other things we can't predict so well. So I can't predict what you're going to be doing tomorrow evening. We don't know. But we already talked about another formula which predicts the future. And that is if you put, say, a cake in the oven, then you use a formula to work out how long you need to put that in the oven. What that formula predicts is that if you keep it in the oven for too long, it gets burnt. And if you keep it in the oven not long enough, it won't cook. So the formula predicts when you take the cake out of the oven. Yeah. So some things you can predict really well into the future. You see, I could predict very, very accurately when there'll be a solar eclipse of the sun, when the sun gets covered up by the moon.
Oh, yeah. Could you get it exactly right? Or
we could predict that to within the seconds.
Yeah.
One thing we're trying to predict, but not very successfully at the moment, is when COVID will finish. And that's really hard because there's so many factors in COVID which are very difficult to kind of deal with.
Yeah.
The best we can do is predict from day to day, really.
Yeah. Yeah.
Although we are doing our best.
Yeah, that's definitely good. What's your favourite invention so far that uses maths technology?
I like inventions. Oh, I think that has to be Google.
Yeah.
So there were two mathematicians called Brin and Page who were in America, and they were studying maths at a university called Stanford, and they came up with this idea for how you could search the internet to find out about things. And they realized that you could write down a formula which would allow you to do that. And that formula became called the page rank method. And that formula is what is using Google.
Yeah.
Think how much you use Google every day. And
Right.
Google wouldn't work if it wasn't based on this formula, which comes from maths.
I use it before this podcast to have ideas to carve pumpkins, because that's what we're doing earlier.
Well, there we are. If you typed pumpkin and carving into Google and it found ideas for you, it was actually solving a mathematical formula to do that.
Very, very important. I like pocket calculator.
Oh, the pocket calculator. Yeah, well, that's a great invention. But I mean, the mobile phone, that wouldn't work without maths. We've already talked about computers, but even things like aeroplanes.
Ah, that's cool. You help to program computers using maths. Is the future of maths technology just computers, do you think?
The way I like to think about this is in about 1400, they invented the printing press. And you could say, well, that might be the end of writing. But actually what the printing press did meant that you could do much, much more with writing. And nowadays, computers don't mean the end of maths. It means you can do more and more with maths. So the future is maths and computing together.
Mm-hmm. Yeah, I agree. All part of STEM. Is there any good website that children could visit about maths?
In the year 2000, there was a thing founded called the Maths Millennium Project, or the MMP, and they founded two websites. So one was Enrich, and the other was plus.maths.org. And Plus is more for older students, so people that might be doing GCSE or A-level. And Enrich is more for people like your age, Jack. And so you can go onto that website. There'll be tons of stuff for you to do.
Oh, yeah, I'm excited for that.
And the other thing you might like is UKMT. I can't quite remember the website, but just type UKMT into Google and you'll find it quickly, which stands for the United Kingdom Mathematics Trust. And they do all sorts of maths competitions.
Oh, yeah. I'm excited for all these maths things. Thank you so much.
No, it's my pleasure. I mean, I think it's really important that people like you are doing this thing. So it's a privilege to work with you, Jack.
Thank you.
And in the future, when you're completely, absolutely famous and totally everything, I'll be able to say, I knew him when he was 8-year-old. There we are.
Yay. Goodbye.
Bye.
That's all we've got time for today. I've loved finding out all about the famous mathematicians and the history behind some of the things that we do today with maths. It's also made me excited about the things that I'm going to go on to learn about when I'm older. I hope you enjoyed this episode and that you maybe feel inspired to look at some of the website or resources we've been talking about, or maybe pass them on to somebody who may be interested. My mum will put anything we've mentioned in the description of the episode as usual. Don't forget to give the orange kangaroo from Denmark trick a go. Join me next time for another exciting episode of Jack to the Future.